Hello. So this is the first video of mathematics for computer science. And yeah, let's jump to it directly. So one of the biggest key factors and metrics that are important in computer science design, let it be the machine design or the algorithm design or the low level code we're making in our machine, the biggest metric is correctness. And the reason why is that so important is because unlike the other engineering fields or systems, we're not resolving a problem for one state or one case, but whenever we resolve a problem in computer science, we're resolving it from all the possible cases or states that exist on that niche problem. And unlike the other fields, when they test like in a heuristic way by doing the possible tests that can happen. Here we cannot test all the possibilities that exist because whatever we're making is close to theory, and uh, in theory there is a lot of possibilities. Let's say it's not a fixed place or a fixed solution, but this is a generic one that can have a lot of possible or infinite solutions. And even if they're finite, they're like in a very big scale. So doing a heuristic or a test coverage doesn't deliver enough certainty for our system's correctness. And even if it is possible, it doesn't deliver it. But most of the time, it's not possible to test all possibilities that exist in this universe. So to prove this correctness in an absolute way, we need to test the solution of our problem in an abstracted way, or let's say in theory, not after implementing it, and we're testing at the implementation of it through fail and trial. And the best way to do that, since the machine behavior and the nature of a machine in computer science is based on math for the most part, so mathematical proofs are the fit to prove this correctness and are the best route to go. Logic proofs are the core of any system correctness we want to prove because in our traditional machines that we have now, their control system or control part is only based on logic, which is conditions and comparisons that are based on logical circuits and or XOR. So everything is based on a logical, let's say, behavior. And another counterexample, for example, if we're working with a quantum machine or a quantum computer, we won't be using just logic, and because the quantum machine works in a probabilistic way, so that would be we should take another route of mathematical proofs there. The book also talk about induction. The first chapter was most of it speaking about proofs, and some of it were logical proofs and just sharing how can you make a proof. Then it jumped to inductions as a proof too. And I'm just gonna explain it and how we implement it and just give a proof of it, or like the tier of it. So in computer science, whenever we have a system that is recursive and that scales in either a finite or an infinite input, the best way to prove it is by induction. We just need to make sure it's recursive and the input is in let's say a real number. I should say integer number, but it's like a unit number, not working an ensemble of numbers that are rational or something like that. And to prove the correctness of a recursive system by induction is assuming that P is the system or the process or the algorithm that takes an input n, which gives us like a Pn as a result. We need to make sure that the initial scale or the initial inputs, like the small inputs, are correct and they work fine. Once we're sure about that, for example, P0, P1, P2, and so far, we can assume that Pn is correct for any n that exists, then we need to prove Pn plus 1 is correct. Once that is correct and we prove it, then by induction, our system is correct. Yeah, so that's most of it for the first chapter. I mean, I didn't finish it. It's just the first 150 pages. And it's mostly about just the basics or the first steps of math, like so you can have them and you can use them as tools in the future of the book to either prove correctness, which is a point on the book, or other points that we could know in the next readings of those chapters. Yeah, that's pretty much it for the video. Thank you for watching, and yeah, bye bye.